And now we're gonna get into another example. This is still under the whole no solution to infinitely many solutions. So what we're gonna go ahead and look at, and we're gonna put this in our matrix. I feel like I keep saying, all right, we're gonna, but that's really all I can say with a lack of people around while I'm doing this. So put this in your matrix, and then we're gonna go ahead and work on it to solve. First step, always, I need that 3 in that top row to be a 1. So I'm gonna go ahead and, let's see, I'll do row 1 minus row 2 for that top piece. That's gonna give me a 1, a 0, -6, and a 4. And then row 2 is the same, and row 3 is the same. Hopefully follow along with that one. I am doing a little bit less steps now that we're getting into the swing of things, and hopefully you guys will be able to start navigating this on your own. Oops, off the board. There we go. Okay, so looks like I have it down. Now I need to turn that 2 in row 2 to a 0. So looks like I can do 2 row 3 plus row 2, because that -1's gonna make that cancel out. So row 1 is staying the same. Row 3 is staying the same in its place. And then row 2 is turning to 0, 3, 6, and -9. All right. Next one, we need to turn that -1 to a 0, so the easiest thing is to do row 1 plus row 3. You can see that 1 and -1 is going to make it 0. I feel like the only strategy to this is going in order, so starting with the leading 1 and then going across and then building back up to row 1 again. It's going to be the most foolproof method. Now, as with any other math thing, you can solve it in a bunch of different ways, but you'll see me follow that process every time because it is the most logical. Okay, so row 1 plus row 3, that gives me a 0, a -1, a -2, and a 3. Yes, that's right. Okay, making sure I was adding correctly. Now we need to make that 3 a 1, which looks like everything across row 2 is going to be a multiple of 3. So I'm going to take row 2 and divide it by 3. That's got to be the easiest thing. 1, 0, -6, 4, 0, 1, 2, -3, 0, -1, -2, 3. So then let's go ahead and we need to make row 3, that -1 needs to be a 0. So let's go ahead and do row 2 plus row 3, because that will make that cancel out. So I have 1, 0, -6, 4, 0, 1, 2, -3, and then adding them together, that gives me 0, 0, and 0, which means that there is no answer actually for my z variable, so it's not determined. So this means if I have a row of all zeros in the bottom, I have infinitely many solutions. And then you're done at that point once you show that. So don't try to go around it and think that you've done something wrong. You haven't, if that's the actual case and you've done everything right, but it has infinitely many solutions.